Let's convert a repeating decimal to a fraction, and the repeating decimal is not directly after the repeating digits do not appear directly after the decimal. There's actually a non-repeating digit before you get to the repeating digits. So what is another way to write this number? This decimal number is going to be 6.039 with a repeating at 39, or the digits 3 and 9 are repeating. So this is going to be the same as 6.0393939, and then we continue in that pattern. So let's go ahead and say that x is equal to 6.0393939 continuously. And then we can see here that our repeating decimals do not happen until after the third decimal digit. So you can see here we have 1, 2, 3. So we're going to multiply this whole number, which is x, by 1,000. So we have 1,000x is going to be equal to 6,039.393939, and we continue that way. Now we have a problem because after the decimal, we need to only have the repeating digits. The only way to do that is to multiply x by 10, because then you can see that we account for the non-repeating digits. So x multiplied by 10, that is 10x equal to 60.393939, and we continue in that order. And then we can now subtract. So this is going to give us 990x equal to 9 minus 0, 9, 13 minus 6, we have 7, and then this is going to be 5979. And now we can divide both sides by 990. Divide both sides by 990. And then we can go ahead and cancel this out. And now we'll divide this by 3. So 5979. So this is going to be, let's do this right here, 5979 divided by 3. We have 1, this is 3, we have 29, this is 9, this is 27. We have 27 here. Divided by 3, we have 9, and then divide 9 multiplied by 3, we have 27, and then we left with a 9 over here. So this is 3, and then this is 9. So we have 1993 divided by 330. So now we can say that x is equal to 1993 divided by 330.